Much of chemistry starts with a chemical reaction. Stoichiometry, you need a balanced chemical reaction. The reaction that we're going to be working with is the reaction of nitrogen gas and hydrogen gas to create ammonia. To use stoichiometry, you need a balanced chemical reaction. That's where your mole ratio is going to come from. Here, nitrogen is a diatomic molecule. Our product should also have 2 nitrogen atoms. So if we put a 2 in front of our ammonia to show that 2 molecules of ammonia are being created, that gives us 6 hydrogens. Since hydrogen comes in the form as a diatomic molecule, that means you need 3 molecules of hydrogen to come up with your 6 atoms of hydrogen. And that is our balanced reaction. Determine the mole ratio of products to reactants from the balanced chemical formula. So the mole ratio between ammonia and nitrogen looks like this. Remember, when you're writing balanced equations, you don't have to write the 1 as the coefficient, but that's what it means if you don't write anything. Ratio between ammonia and hydrogen looks like this. I'm just getting these numbers from the balanced chemical reaction. There is a lot of information in just one chemical equation. The first thing I can say is that this is a synthesis reaction. We have more than one reactant forming one product. Using the balanced chemical reaction, I could say that 1 molecule of nitrogen gas reacts with 3 molecules of hydrogen gas to form 2 molecules of ammonia. This is just a ratio. I can say that I have 1 dozen nitrogen gas molecules reacting with 3 dozen hydrogen gas molecules to produce 2 dozen ammonia molecules. A mole is just an amount, so you can also say that 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas to produce 2 moles of ammonia. What you can't do is just use the balanced equation alone to figure out the amount in grams you would need of a certain reactant to make a certain amount of product. You need another piece of information. Molar mass can get you between grams and moles. Whenever you're working with stoichiometry problems, it's a really good idea to do the molar mass calculations for all of the reactants and products that you're dealing with. Remember that this information can be found on the periodic table. Every atom of nitrogen weighs 14.007 atomic mass units. The mass number also tells us the amount of grams that 1 mole of those atoms would weigh. Nitrogen gas is diatomic. So to figure out its molar mass, we take 14.007 and multiply it by 2.